So hello everyone, today I would like to discuss a stress testing project. Now what I have done in this, I keep on sending connections to the TLS. Now what is TLS? Let's look into that. So TLS is nothing but the security protocol when it comes to the HTTPS. Now talking about the before protocol, the first one was the HTTP, which wasn't any secure, so there was no particular cipher or algorithm to assigning a particular security for particular session. Then there comes the HTTPS now, which all the sites currently uses, which has a security feature in it, and that is TLS. Earlier it was SSL, now the TLS is what works with. So the first sender sends the synchronization, and then these from the receiver end they sends the synchronization and acknowledgement, like they establish like, oh, a particular request was sent to me. Then the acknowledgement, oh, we have this port available with us, would you like to have it? Then here comes the part of TLS. This was the part of TCP in the application. Then the hello is sent. Here the particular servers gives back the server hello certificate, and so gives on. And there is the cipher algorithm which assigns a particular security key for that session so that nobody else could access that session. Now I have designed a stress test for the TLS session. So firstly we need a particular certificate and a security key in order to make this TLS server. So for that we have this command open. This creates that. Let's just remove it because it's already done, and you can check this using accessing the server CRT for the certificate and the other server key. Okay. Just a second. This is the folder, and after accessing the folder I have a nano server file in it. Let me show you the server code. So as you can see, we have a socket, we have SSL, we have threading. Now threading is performing multiple tasks at a one period of time and doing it concurrently. So every particular, like I have one server, but that server would be dealing with multiple clients. So those clients are virtually defined, and there aren't actually multiple clients, but the other terminal would be acting as sending concurrent requests at a single period of time. So sending one particular client would be sending 5, and another client would be sending other 5. So there would be number of requests at a single same period of time. That thing is done through the coding part and with the help of threading to actually showcase that there are multiple clients that are sending the request at a same period of time. Then thread logs, you can have the logs and OS, date, time, and everything. Log file, you can serve all those save all those logs in the server.log if you want to. Now the most important thing is like you can see like there are connections, and it assigns like other things ignoring, and the socket is over defined, like what kind of socket we are dealing with. And we have S stream because this is my S stream is one which we deals with TCP, and there is the other one that is used for the UDP. So S stream is for the TCP, and TCP is so when we are talking about different layer, we have TCP, then there is this session. So HTTP, as you can see in the diagram, we have HTTP for accessing the routes, then there is TCP, and then comes the security part. So that is TLS. So handshake, like I was talking about the handshake, so it has this sign like whether the handshake is failed or not. Then shutting down the server. Now it has host, it has port, it has the certificate that we needed for our server in order to create that, and we have the key. And let's just close it. Okay, let's just run our port dot server dot python. Okay, we have the port 8443 and I have my host at particular 0.1. So I've started the TLS server and I have this another script in here in the same folder. It's called client.py. So it sends one signal at a time. So as you can see, it is trying to connect to the particular host number that I was talking about earlier. This is the IP, then the port. So the I've already default it as 8443. Then the argument, the message is whatever data we are trying to send. That is hello from the client. As you can see, here are the service reply. Server will be giving us the reply and the round trip time, which is like the time it took to do the async, async and everything all back to getting the acknowledgement from the client. So that's what it deals with. Let's send the request. Now to send the request, we have client.py host 0.0.01 port 3. So as you can see, we had the first request. So serving on this was already seen to us. So it says connected. The connection was established, received something, and that something was hello from this client, and then we disconnected it. Okay. As you can see, it keeps on showing the same message of disconnected because I'm not connected to any internet because of the false certification and all that code. Okay, now I have this another code where I will be sending multiple requests at a period of time because I want to stress test it, and the name is also similar, so it's stress test, as you can see. So it will be using threads, socket TLS, as we have seen earlier, and it will be sending multiple arguments, so the range, concurrency, and it joins the thread. So when everything is connected, then only all this part is of parallel programming, and then it gives you the average RTT. Like we will be sending multiple requests, so what would the average time of one particular request? That's what it will calculate. Okay, now we have so let's move on to the stress testing. So this is stress, and as you can see, we are going to send concurrent requests from 5 different clients, which means I'm actually just showcasing like there are 5 different clients that sending 5 requests at a period of time. So 5 into 5 will be 25 requests sending to our server. So let's do that, and saving everything in this particular file, all those requests. As you can see, there were multiple requests and the total requests were 25, and all those requests were successfully sent to that particular server. The average time, the round trip time to send one particular request, as you can see, it's here. So it's pretty small number. And the other thing you can do in this project is you can check the memory that was used or how the CPU dealt with all those 20 requests. So there is a command called stop p, and it tells you like what 20 requests were done and how much energy it consumes of your CPU. So not much, but yeah, memory was consumed almost 0.3, and everything, as you can see, the average time and the task. Now this session actually tells you how long this particular Kali machine was running, but you can actually test it as soon as you open your terminal and you close it and then test it. Then it will give you much more clearer value to assign with. So this was stress testing project that I built. Thanks for watching.